Hello everyone, welcome to the lecture of applied physics. Today we are going to discuss about the quantum mechanics. So what is exactly quantum mechanics is? So in this lecture, first of all, let me discuss about what are the topics we are going to discuss about. So actually quantum mechanics we are going to discuss about some of the major topics as the black body radiation, photoelectric effect, de Broglie's hypothesis, G.P. Thomson experiment, Heisenberg uncertainty principle, Schrodinger wave equation and particle in one-dimensional potential box. These are all some of the topics what we are going to discuss as far as the quantum mechanics is concerned. Now, but before going into the quantum mechanics, we have to discuss about what are the theories available to us before this particular introduction of this quantum mechanics. This is in the beginning of the 20th century, that is at 1900. In that period, actually there is a necessity for the scientists to introduce a new theory. That theory is nothing but the quantum mechanics. What is the necessity of introduction of this quantum mechanics? To know the necessity of this quantum mechanics, let us try to discuss about the classical mechanics and quantum mechanics, because before the introduction of this quantum mechanics, the only theory which was available was only the classical mechanics. What exactly classical mechanics is going to deal with? So classical mechanics is that branch of physics which is going to discuss about the macro particles. Macro particles are those particles which are large in size and which can be visible and which can be seen with the naked eye. It means if any body is moving, so we can find out its velocity, momentum and etc. by looking into that particular particle. We can easily estimate that particular dimension of that particular particle. But after the introduction of these microparticles, scientists thought that they can explore these particular particles also by the postulates whatever are given by using this particular classical mechanics. But they failed. They could not able to explore these particular tiny particles by using the postulates of classical mechanics. Why is it so? Because classical mechanics says that energy is continuously released. Whenever the particles are moving, the energy is released continuously. But as far as when it comes to the microparticles, this is not true. The energy is not released continuously. So that is the reason here the classical mechanics failed here. That is later quantum mechanics explained us that energy is not released continuously, but rather the energy is discrete energy is released by these particular tiny particles. Tiny particles in the sense atomic and subatomic particles. This is one of the reasons why the scientists wanted to introduce a new theory, that is nothing but the quantum mechanics. And one more, the major difference between the classical mechanics and quantum mechanics was this classical mechanics is the completely real world. Real world in the sense whatever we see, so the motion of the body or whatever, any object, whatever we could able to see with the naked eye. So that particular motion of that particular body, everything which is easily we can estimate everything. But why the quantum mechanics is weird? Because here quantum mechanics is very difficult to understand, people think. So even that is true also. So because even now also the quantum mechanics we are unable to explain fully, because it is a weird world. Why I am saying it as a weird world? Weird world because here the quantum mechanics, here the particles, whatever in classical mechanics we could able to see the particles with the naked eye. So that is easy to understand. But when it comes to the small particles, here the atomic and subatomic particles, so here we can't see these particular particles with the naked eye. And the understanding of the characteristics or the motion of these particular particles is very difficult. So that's why it somewhat we feel that it's a weird world. Okay, that is one of the reason why the classical mechanics failed to explain the tiny particles properties and characteristics. And not only that, one more major difference between the classical mechanics and quantum mechanics is classical mechanics understands that the particle and waves are two different entities. So, particle is on one side and the waves are on the other side. It means particles have definite mass and velocity and all its other characteristics. And waves, as we know, it is not a physical quantity, where a particle is a physical quantity, we can measure it with its mass, position, momentum and etc. But coming to the waves, wave is a non-physical quantity and we can't see that where is a wave is, but we can estimate the wave by using its characteristics like its amplitude, wave nature and all the other things. But quantum mechanics says that both particle and waves are coincide, that is the wave particle duality. So, quantum mechanics understands that the particles are wave and particle nature as a dual nature. So, those particles they have named it as an matter waves. So, this is what the major difference between the classical mechanics and quantum mechanics. That is the reason at the beginning of the 20th century, that is in the early stages of 1900, so scientists thought of introducing a new branch of physics. So, because one medicine cannot cure all the diseases, so even here also one theory cannot explain all the properties of everything in the universe. So, that is the reason. So, Max Planck was the person who explained about this particular quantum mechanics, the need for the introduction of the new theory, that is quantum mechanics. After that, so many scientists came into the picture, so who wanted to explain this quantum mechanics theories. We are going to look into all the other parts of this particular quantum mechanics. Thank you.